Now we're changing gears and looking in the probability world. So first, we're told we're taking a multiple choice test that has 10 questions. Each of the questions has 5 choices with 1 correct choice per question. If you select 1 choice per question at random and leave none blank, how many different ways could you answer the test? Okay, this is an example of the fundamental counting theorem because you're having to make several different choices. Like for each question, you have to make a choice. So you have a total of 10 questions. So what we usually did is drew 10 blanks. I think that's correct. Yeah. So then we're making a choice for each one of those. And if you look, there are 5 choices for each question. So we put 5 in each blank. To get our answer, we then multiply all these 5s together. A shorter way to do this is 5 times itself. A total of 10 times is just 5 to the 10th. So if we type 5 to the 10th in the calculator, that will give us our correct answer. So you get 9,765,625. Okay, now 45, we're dealing with something a little different. We're told we have 7 drummers to choose from to make a schedule for a talent show. If there are only 5 spots for drummers in the talent show, in how many different ways could you arrange the 7 drummers? So here, it's more so that we're trying to choose something from a group. We have a group of 7 drummers and we want to choose 5 of them. So we're taking a portion of a group. So this is when we deal with combinations and permutations. Just a reminder, permutations are when the order does matter. Combinations are when the order does not matter. Now here we're making a talent show, we're doing a performance, so order certainly does matter. Think about anything involving a schedule, the order matters. Just like when you go to a concert, the band that's just getting started opens, then somebody you may or may not have heard of might play after, and then the big name is the one who plays last, so the order does matter. So we're dealing with a permutation, and there's a total of 7 that we're dealing with, and we're choosing 5 of them. So 7p5. In your calculator, type 7, go to math, then all the way over to probability, and NPR stands for the permutation. This does the calculation for us. We do 7 NPR 5. And we get that there are 2,520 different possibilities for making this talent show schedule. Okay, now this next one says of 10 possible movies, you can plan to take 4 with you on vacation. How many different collections of movies can you take? Okay, so this one the order does not matter, because whether I choose the movie first or fourth, it's still going with me on vacation. So it doesn't really matter what order I pick them in, just if they get picked, they go with me on vacation. There are 10 in the set, and we're going to choose 4 of them. So we'll do 10C4. We're doing combinations again. The reasoning is it doesn't matter what order we pick them in. So we do 10, then go to math, go all the way over to probability. Use number 3 for NCR's combinations. Type in 4. And we get 210. So with just 10 movies, if you're trying to pick 4 of them to go with you, you've actually got 210 different combinations. Okay. 47, switching gears now, we're talking actual probability. Notice the others, the previous 3, 44, 45, and 46, we're saying how many different ways or how many different combinations or collections could you make. 47 starts actual probability. So it says if you randomly choose a card from a normal 52 card deck, what is the probability of selecting a 7, a 10, or a jack? Now notice this is or. Whenever we have or, we're going to add them together. So we really need to figure out the probability of doing a 7, then add that to the probability of getting a 10, and then add that to the probability of getting a jack. There are 4 7s in a 52 card deck, so the probability of picking a 7 is 4 out of 52. There are 4 10s, so the probability for that is the same. And there are 4 jacks, so all 3 of them have the same probability, 4 out of 52. Now if we add all of them together, we get 12 out of 52, which reduces to 3 over 13. 48. If you roll 2 dice, what is the probability of rolling 2 numbers whose sum is 9? First of all, when we roll 2 dice, there are actually 36 different possibilities. When we roll 1 die, there's 6 possibilities. When we roll 2 dice, there are 36 possibilities. So I know already on the bottom of my fraction will be 36, because that's the total number of possibilities. But I need to figure out how many different ways I could get a sum of 9. I could start by getting a 3 and a 6. I could roll a 4 and a 5. I could roll a 5 and a 4, or a 6 and a 3. Now it may feel like we're duplicating doing these two and these two, but you got to consider the dice as two different things. So you can almost think about that first line as that's what happens if the first die we roll is a 3 and the second one's a 6, while this last one's if the first die is a 6 and the second one's a 3. So that is considered two different things. So there are 4 ways for us to roll 2 dice and then add up to 9. So 4 out of 36, or reduces to 1 over 9. Okay, there are 6 pennies, 7 nickels, and 11 dimes in an antique coin collection. If 2 coins are selected at random without replacement, find the probability of selecting 1 penny and 1 dime. Okay, so first of all, let's notice that we have a total of 6 plus 7 plus 11. That is 19. No, let me try that again. That is 24 total coins. Sorry, it took me a second. So 24 coins in total. 24 coins we're dealing with. And we're going to pick 2 of them out of this group. And notice it says without replacement. That right there tells us the answer to the fact of whether it's independent or dependent. Since we're picking a coin out and not replacing it, that makes it dependent. Meaning what we do the first time does affect what we do the second time, because if we pick a coin out and don't replace it, then when we go back in for the second coin, there's now only 23 coins, and that's going to change the probability. So let me write it this way. We have 6 pennies, 7 nickels, and 11 dimes, equaling 24 total. So it asks, what is the probability of picking 1 penny? So we'll start there. 1 penny, well, there's 6 of those out of 24. But if I pick that out and don't replace it, that narrows me down to 5 pennies and 23 total coins. So when I go for my second coin, wants to know the probability of it being a dime. Well, there are 11 dimes, but now there are only 23 coins in total. Okay, and sorry, I made a mistake here. I shouldn't be adding because it's not this or this. It's doing this and this. So actually multiply these two together. Sorry, I wrote that incorrectly. We multiply these two together. Anytime we're dealing with independent and dependent, we're going to be multiplying. Anytime we're dealing with and, we're going to be multiplying the two probabilities together. So we'll do 6 over 24 times 11 over 23. So the probability is that decimal, or you can also change it to a fraction and get 11 over 92. So that's the probability of, in this set of coins, picking 1 penny and then 1 dime. Okay, next we're talking about mutually inclusive or mutually exclusive. So determine the probability of selecting a boy or a One Direction fan from, and I'm going to write this out, 13 girls, 10 of whom are fans, which we'll pause there. If 10 of them are a fan, that would imply 3 of them are not. And 12 boys, 3 of whom are a fan, meaning the other 9 are not. So that's the group we've got. We've got a total of 25 people. 13 girls, 12 boys, 25 total. And within the girl group, 10 of them are fans of One Direction, 3 of them are not. Among the boys, 3 of them are fans and 9 of them are not. So is this event mutually exclusive or mutually inclusive? Mutually exclusive means the two things cannot happen at the same time. For example, we cannot be a boy and a girl at the same time. Or, if you think back to the previous example, when we're picking 1 coin, it can't be both a penny and a nickel at the same time, not 1 coin. Mutually inclusive means it can be the same, or can happen at the same time. So as we look here, we're looking at selecting a boy or a One Direction fan. And it is possible for someone to be both a boy and a One Direction fan. You can see that group right here. Those people are both boys and One Direction fans. So this is mutually inclusive because the two things we're looking at can happen at the same time. So when we're mutually inclusive, we do it this way. The probability of a boy plus, and we do plus because we're doing or, the probability of it being a One Direction fan minus the probability of it being both. And I'll explain a little bit more about why we have to do that subtraction there at the end. So the probability of being a boy, well, if you look, there are 12 boys out of a total of 25 people. Probability of being a fan, right here, we've got a total of 13 fans out of 25 people. But then we have to subtract the probability of someone being both a boy and a fan. That's right here, it's 3 out of 25 people. So we add all that together and we get 22 over 25. That's the probability from this group of us randomly picking one person and it either being a boy or a One Direction fan. Now I just want to try to explain why we have to do that subtraction. If you look, the first thing we did was find the probability of being a boy. So that covered all the people in here. Then we wanted to find the probability of it being a fan, which would cover all the people in here. So if you look, this group right here got counted twice because it got counted in the boy group and in the fan group. So to correct for the fact that it got counted twice, we had to subtract them one time. Just so you know, with mutually exclusive, you don't have to do the subtraction because the probability of them being both will be 0. So when we're mutually exclusive, we don't have to subtract anything. It's only when we're mutually inclusive we have to worry about that. Okay, we are finally to the last question. So the following represents the attendance at the Kentucky Derby over the past 15 years in thousands. So when we have this list like this, we need to go to our calculators, go to Stat, go to Edit, and then you can plug all the numbers in L1. You just type them in, hit Enter after each one. I already have these plugged in. As we look, it's asking for the mean, the median, the mode, and the standard deviation. Okay, it's actually easiest if we start by looking at the mean, the median, and the standard deviation. So let's do that and we'll come back to the mode. To find this, we go to, I'm going to hit Quit, and then go to Stat, Calc, and enter one variable statistics. Make sure the list is the name of whatever you put it in. We put ours in L1, so we're good to go. And we're told that very first line, X bar, that's the mean, so it's 143.8. The median, we actually have to go down a little bit. If you go down a little bit, MED, right there, second line from the bottom. The median is 148. For the standard deviation, we'll go back up to the top, and the fourth and fifth lines both represent standard deviation. The fourth line that says SX is probably the best one for us to use here because that's the sample, and we're just dealing with a sample. These aren't all the Kentucky Derbies ever, so it's just a sample. So you could write 15.38. The one right below that looks kind of like a very small cannon or an O with a little hat. It's called sigma. Sigma X is if we're dealing with the entire population. I'll honestly accept either one of those on the exam. So you can write 15.38. That's probably the better answer, or 14.86, which I think is what I have. Our textbook likes to use the sigma, but from what I know about statistics, we really should be using SX. But I'll accept either one on the exam. So just know that it is SX and sigma X that give us the standard deviation. I'd prefer to use SX, but I'll accept either one. Last thing is to find the mode. The mode is the number that appears most often. Now if you want, you can just kind of manually look through this list and see if you can notice the one that appears most often. In a list that long, that can be kind of tough. So what I would recommend is go back to your calculator, go to Stat, and number 1 is Edit. That's where we can change what numbers are in there. But if you look at number 2, That means sort ascending. That means it will sort the numbers that we just put in there and put them from smallest to largest. So if we hit enter, we have to tell it what we want as a sort. So hit second and then the number 1. That plugs in L1. We'll close our parentheses and hit enter. And then it brags about the fact that it's done. So we go back to stat, go to edit, and we can see our numbers in order. It's really easy now if they're in order to see if there are any duplicates. So we've got no duplicates hit here, so I'm going to keep scrolling down. Okay, there we see some. 151 shows up twice. So let's see if anything else shows up twice. No, that's it. So just a reminder, it is possible to have more than one mode. If two numbers appear twice, then they would both be the mode, but here just one number appears twice. It is 151. Whatever number appears the most is your mode, and for us that is 151. Okay, my friends, best of luck to you. Make sure you study hard. Feel free to come talk to me if you have any questions.